Hello, I'm Richard with EV4U Custom Conversions, and in this video we're going to talk a little bit about regenerative braking. Now, regenerative braking is simply the act of the vehicle being braked, slowed down, decelerated by the electric motor. The same traction motor that provides propulsion is now going to provide braking. And it does that because it's electronically turned into a generator, let's say. I'm oversimplifying everything, but it basically becomes a generator. And instead of the battery pack taking energy, instead of the traction motor taking energy out of the battery pack and propelling the vehicle, now it's going to be taking that kinetic energy of the vehicle rolling down the road, and it's going to produce, generate energy and put it back into your battery pack. Now, it's not a one-to-one kind of thing. You're always going to use more energy propelling the car than you're going to get back decelerating the car. And the reason for that is mainly the time component. So the amount that you can put back into your battery pack, the amount that you can regenerate, is going to be based on your speed and the time. So what happens in a regenerating scenario is you let off the throttle, you're experiencing regenerative braking at that point, and so the vehicle is decelerating. And so the speed at which you start to decelerate and the length of time that you decelerate is what's going to determine the amount of energy that goes back in your battery pack. So it's easy to understand that the more, the higher the level of regenerative braking, the more current that you're putting into your battery pack, the quicker it's going to decelerate you. And the quicker you decelerate you, the shorter period of time that you're going to be regenning. And so it's not a way to really recuperate any energy unless you're going down a grade and gravity is providing the energy. But in a typical stop and go driving scenario, it just gives you a little bit of energy back. You're going to expend more to accelerate than you're going to recoup in decelerating. So there's a couple methods used in regenerative braking. And we're going to see an example of all the methods. And they are the most common. You have regenerative braking when you let off the throttle. So it kind of replicates the compression holdback in an internal combustion engine. You let off the throttle, and you've got compression that is holding you back once the throttle is closed. Well, like I mentioned a minute ago, in an electric vehicle, the motor turns to a generator. Your generator energy into your battery pack, and that, if you've ever turned like a hand cranked generator, you can spin it fairly easily till you put a load on it. And once you put a load on it, then it's hard to crank. Well, the load in this case is the battery pack itself. And so you're taking kinetic energy and producing it to electrical energy and force feeding it into your battery pack. So the throttle is one way, one form that we're able to produce regenerative braking. The other two are with the brakes themselves. So as soon as you activate the brakes, it produces regenerative braking. And it can increase that amount or just add a similar amount, whatever. Whoever manufactures, designs this vehicle can determine how that works. And the other is a variable rate based on your brake pedal pressure. And so the more brake pressure you apply, the greater the regen. And we'll see that on the e-Golf when we go for a little ride, that as soon as you touch the brake, you get some regen. The more you apply the brake, the greater the regen. And so those are the most common ways that electric vehicles decelerate, is with regenerative braking. But many of them also give you another option, and it's really based for efficiency. You know, regenerative braking is nice. It gives you that one pedal drivability. I really love driving electric cars. Matter of fact, I don't even own a gasoline car anymore. But another advantage of that is that your brakes, your mechanical brakes, your kinetic brakes, last a long time because they're not being used as much. You only use them to bring the vehicle to a complete stop. But in most situations, the regenerative braking is going to do the majority of the decelerating. But some electric vehicles give you another option. It's not regenerative braking, it's coasting. So it gives you the option of when you let off the throttle, then it just freewheels. The vehicle just coasts. And the premise behind that is that you actually get more range by coasting than you do with regenerative braking. Because regenerative braking is doing just that. It's slowing you down. If the goal is to go from A to B, if you can put a little bit of energy in and then stop putting energy in and be able to coast, use that momentum, you're gaining distance without energy, without applying more energy. And so it's an efficient way to go. And you know, if you're going down a slight grade, coasting may be all that you need to maintain your speed. So you've got the force of gravity drawing you down the hill, but you've got the force of aerodynamic drag holding you back. But if those two are equal, you can actually be moving forward with no loss of speed and with no energy applied. And so that's, you know, a great benefit. Then if you had a steeper grade where you needed to maintain your speed, you can apply regen and slow yourself down. And that's where I really like the e-Golf, is that it has 4 layers, or 4 levels, 4 levels of regen. So you can have a little bit, and say the grades get steeper, or people are slowing down in front of you, you can increase that. And you have 4 levels of increasing amounts of regen. But my typical driving, I just use maximum regen or coasting. And so typical scenario, driving down the freeway, I have it in coast mode, and you're getting close to your off-ramp, let's say, I just cancel the cruise control and you just coast off the freeway. You get down to the end of the, partway down the off-ramp, hit the regen, slows me down, and I'll hardly have to use the brakes at all. And so anyway, we're going to discuss that in this video, and mainly the rest of the video. I've already discussed it, haven't I? The rest of this video is going to give you some examples, show you some visual aids that will help you get a feel for all this. The e-Golf has some nice instrumentation, and you'll get to see the amount of energy and the amount of regen in quite a swing. It's over 180 degrees of swing. You'll see that. It's also a digital display, which we're really not going to look at that part. And then there's also a graphic that shows which way your energy is going. It shows it going from the battery to the motor, and the tires turning and you're going. And it shows from the ground, through the wheels, to the motor, and back to the battery, in the direction the energy is going. Or that you're just freewheeling and no energy is being put back in the battery or being taken from the battery. So you'll get to observe that in kind of a real-world setting. And hopefully this gives you a better understanding of regenerative braking. We're going to use this Volkswagen e-Golf to illustrate regenerative braking. we'll see on the screen here, it's showing a vehicle. This is our battery pack, this is the motor, and you'll see when energy is flowing from the battery pack to the motor and when energy is flowing from the motor back to the battery pack when we're regenning. So it'll show, power from the motor to the wheels and so forth. You'll get the big picture. We're also over here, we're going to show the economy. We're going to see the the miles per kilowatt hour consumption rate. And this one right here will give us a representation of the energy being used and energy being regenerated. It's a really visual aid in showing your efficiency. And so we're going to use two regen modes. We're going to use just regular drive, which is a coast mode, and B for braking. The e-Golf actually has 4 modes plus coast. So we've got coast, we've got what they call recuperation stage 1, regen stage 1, regen stage 2, regen stage 3, and then brake, which is the maximum regen. So we're just going to go between the maximum regen and coasting. So let's get started, and you'll see as I give it some throttle, energy's coming from the battery to the motor. The wheels are turning, and we're moving down the road. When I let off the throttle, you can see it's going back the other way. Okay, so let's get up here. We'll get moving a little bit faster. You can see how things go. No energy, we're sitting, well, stop. We're sitting still. No energy is being used. Energy coming from the battery pack to the motor, and away we go. Now I'm going to let off the throttle. You can see we're regenning, and we're decreasing in speed. Now we'll get going again. I'm going to put it into coast. This time I let off. You can see energy from the wheels is going to the motor, but it's not going back to the battery. I'm just coasting. And this is fairly level ground right here, and we can coast a long way with very little change in our speed here. And you can see coasting here, no energy being used or put back. As soon as I hit the regen mode, boom, it starts putting energy back. Give it the throttle, we're drawing some energy. Give it a lot of throttle, a lot of energy. Okay, so it's like I said, it's a good representation. And this is, when it goes to regen, of course, you're not consuming any energy per mile. So now, as I'm on the throttle, it shows that we're, consuming so much, or we're going to get a certain amount of range. And so that's instant. We can go up here to look at the average economy. So right now our average economy is 14.6 miles, or 4.6 miles per kilowatt hour. The national average is 3.1 miles per kilowatt hour. So I'll give it a little more throttle here. We'll get going. I'm gonna let off the throttle, and look how long we can coast. You actually get more range by coasting than you do with regen, because as soon as I hit the regen, yeah, we're putting some energy back in, but we're slowing down, and the amount of energy that's being put back is less and less and less as our speed decreases, until it's none at all, and we're almost at a stop. Okay. Do the same thing. Put it in coast. We're not putting any energy back, but we're not taking any energy, and the distance I'm traveling is much greater. Now, regen is really great if you're going down a grade to hold back your speed and to recoup some energy. It's great in that case. If you're in stop and go traffic, it's good in that case. It gives you this one pedal drivability. I can speed up, slow down with just one pedal. And of course, with this one, I can choose the percent of regen by just moving the shift selector here. But typically I would leave it in maximum regen. And I only coast when I'm on the freeway. You're running on cruise control. You disable the cruise control instead of it regenning and slowing you down right away. It just lets you coast, and then I can select the regen when I want it or don't want it. So like right now, going downhill, we'll just coast all the way. You can see my speed is staying very steady, starting to drop as we level out here. We'll go over the kind of crown of the hill right here. It'll actually start to pick back up. Put it in regen, slow down for the stop sign. Put on the brake a little bit. Now, the e-Golf has multiple features as far as the regen goes. So it will regens when I let off the throttle, and get up a little bit of speed here. So it's going to regen when I let off the throttle. And you can see it's up there pretty high, but as soon as I give it the brake, it regens even more. So it's a variable rate on the regen with the brake applied, and it's also variable through this gear selector as far as the amount of regen when you let off the throttle. Now, with most conversions, we can do the same thing, and with the high performance electric vehicle systems, we have 2 regen levels we can choose, as well as you can have the brake input. We don't normally use the brake input on most vehicles, especially ones that are light, because you can have too much regen. I mean, we could lock up the drive wheels, you know, if we wanted to, just with regen. And so it's really a matter of what's best for the situation. So most vehicles, you don't want to have too much regen, especially if it's rear wheel drive, because you don't want to break traction. You can get away with a little more regen, and especially when the brakes are applied also with a front drive vehicle, because most of the braking is done by the front wheels. And so having aggressive regen, just like putting on the brakes, if you have aggressive regen and it's rear wheel drive, it's like pulling on the parking brake. And that's not a real good idea, depending on your speed and how much brake is applied. So I hope you can see between the instrumentation and the dash here, the display here, what's going on when we're driving and regenning. So you can see that needle fluctuate. A lot of fluctuation. I really like the instrumentation on this vehicle. It's very good at giving you the information to drive efficiently, and it also gives you your range, travel time, distance, average speed, your economy we talked about, which instant economy and average economy. I usually leave it on the average economy because this gauge right here gives me the instant, consumption rate, and this is telling me basically what my average is, and based on that average and the capacity of my pack, I know how far I can go. I don't need it to calculate the range. It calculates the range based on your historical driving habits. So that's an introduction to it. So we'll talk more now about how do we use and work the regen on a conversion, and we're going to use our sandrail as a platform for explaining that. So here we are at the display end of our sandrail that we use in our workshops, and we're just going to show you a little bit of the settings that you can do for regen, and in this case specifically on the high performance electric vehicle system setup. This is an AC50 using the Curtis 1238 controller. So this is just a 72 volt nominal setup. We got our JLD on the amp setting right now. We're showing 78 volts. So that's amp hours. So what we're going to show is we're going to watch the amps, and we're going to look at the settings on the Curtis 840 display. This monitors the inverter and the motor. So we'll turn it on first and just give you a reference here. Turn the ignition on. This is our light to let us know that the ignition is on. So between the inverter and the DC to DC converter, we're pulling about 1 amp. Okay? And so I'm going to give it some throttle. We'll see the RPMs change. We'll see the current change. Okay. Goose it a little bit there. You can hear the regen stop the motor faster than the gauges can keep up. So here we'll go again. You see we're pulling current, and let's see if I can, with no load, the regen stops it pretty quick with the amount of regen we have programmed into it. So what we're going to do is we're going to do some programming on this and show you what it would be like to have a coast mode and how easy that is to set up. So we're going to turn off our ignition, and to go into the programming mode, we're going to push the menu button here and turn the ignition back on. So it says ready, program ready, and you can set your throttle, your brake settings. We're going to the controller limit here, or current limit. So we've got the normal regen braking at 68%. We got the economy mode at 68%. Okay, and this is the shift neutral braking, which we don't use. This is the regen current, the braking currents at 100%. And we have 100% of the current available going to the motor from the controller. And on the economy mode, we're only using 58% of that current. Okay, let's go back and change the setting so that on the controller current will go to 0. so it will just freewheel. So normal regen rate 68%. We're going to change this now to 0. There we are. So 0. We'll let it go through, save it, and then we'll spin it up and you'll hear the difference. So you've got a lot of flexibility on this, where you can change the amount of braking force as well as the regen percentage also. Okay, so now we're going to use this switch right here. It's going to switch between our normal mode and our economy mode, and you could call it winter, summer, normal, daughter mode, valet mode, whatever. And you saw you can set all different parameters for the two modes. So we set the 1, so we'll have 0 regen. So we'll turn things on here, and with it in the normal mode here, we can hear it regen. Stop that motor pretty quick. Flick it to this other mode, it's just freewheeling. Turn it back there, regen kicks in, drops it down. So no regen, regen. And you know, of course, I have a key switch here, but it could be a push button switch, it could be a toggle switch, it could be however you wanted to switch it. And so just wanted to show you, you saw the regen in a factory produced, the Volkswagen e-Golf. So here we have 2 modes also, and they're programmable to whatever you want, you know, to set them at. And so if you want to freewheel, you just press a button, freewheel, press it again, regen. And that's what we do on a lot of our conversions. It's just a button on the dash, and you press it and you've got coast mode or normal mode. Okay, so what we just demonstrated with the sand rail was regen that was throttle activated. So whenever you let off the throttle, it produced a % of regenerative braking. Now, this high performance electric vehicle systems also offers 2 modes of regen that is brake activated. So one is that once it receives a brake signal, so once you just tap the brakes, you have a % of regen that you program. You also have the option of having using a brake transducer and having variable regen based on brake pedal pressure. Okay, and so you have 3 modes of regen, and with the throttle you have 2. So there's a total of 5 different modes of regen possible with the high performance electric vehicle systems setup. So that's pretty much what we were going to talk about in this video. We gave you some examples using the nice displays in the e-Golf to show what was going on. We audibly and visually got an idea what's going on with the HPVS system. And if you have any questions, email us at info@evforyounow.com. Thanks for watching.